record it. Yay. Okay, so here we are, exam review session. Can we minimize you? Yes, we can. Can we do it? Yes, we can. Bob Goat.
I like the Bills shirt. They
Thank-
played really well last night.
Yeah, they scared me a little bit in the first half when they were up 10-0 and they were tied at halftime. I was at a bar watching it and then I decided, you know what? I don't want to be around other people while I watch my game. Go home and have time. All right, so here we are, review session, yay. And so here are the topics. It's good. I always did this when I was reviewing for an exam myself, right? Just like try to organize. And that's actually been my principle as an engineer. Anytime I'm overwhelmed by something, I just keep organizing. So like make a list of all the different categories of problems. We had fundamental kinematics on the first day, projectile motion. And that is a constant acceleration problem, sort of like a subset of the constant acceleration problem. And the constant acceleration is a subset of the fundamental kinematics problem. And we had relative motion. We had constrained, aka dependent motion, which is really pulleys. Then we had one through kinematics in rectangular coordinates. And then we had introduced a coordinate transformation, and then we did path coordinates and polar coordinates. And that's a lot of stuff to have an exam over. I used to do exam 1, we included some stuff from Newton's second law in there. It just made too much stuff. So I said, you know what? I expanded it to 5 classes. This whole topic used to be in 3 classes when I first started here. And I said, that's not enough. So we expanded to 4 classes. I said, that's not enough. So we made it 5 classes. And then now you know the history, and it didn't really matter to you anyway. But that's okay. You get to hear the story. So here is the equation sheet. I meant to print some out, darn it. And I can't print from here. But anyway. I would suggest, as you're studying, by the way, I'm stopping myself. Sometimes I correct students, and it's a pain. I know, it's an act. I just use the word study. Don't even think, don't even use the word. Don't even use the word. It implies you're going to read something. We're not going to read anything. We're not going to look at problems. We're going to do problems. It's the only thing. By the way, the secret. When I became a professor, it was after, I became a good student. I used to be a lousy student reading and recording. I'm not going to swear. Try not to swear. My nature is swear. But I found the secrets, right? Like I was so scared that I was going to fail out of college because I went to Tennessee high school and I just thought perhaps we're going to have like a shitty. It turns out I went to a great high school compared to everybody else because my teachers didn't let me use calculators and I had to do all the calculus and stuff without a calculator and that kind of thing. But it just made me better at math than a lot of my cohort. Right? I know in my English class, I'm much better writer than the average student. I didn't realize that, but because I was with a bunch of smart kids I was the dumbest kid, amongst the smart kids. But anyway, I learned how to study. Get rid of the word study. I just started practicing problems, and all of a sudden, boy, and it's a lot of work, but you get better at it, and you get better at it, and it becomes easier, and you can actually become more efficient. You could get a better grade with doing less prep work than other people do just by working through those problems. And if you trust me on that, and I discovered it, and I tried to share it with my classmates, that kind of thing. And I became the regimental academic officer at the Merchant Marine Academy, and I tried to help people. And then later on, when I became a professor, I'm like, I know the secret to doing really well in all these courses, and just keep practicing problems. And so if you want to practice the right way, you simulate the exam. Do exactly what's going to be like the exam, pretend it's a little mini exam, right?
Can you email us this sheet so we have it when we're doing our practice problem?
Sure, but it's already on Blackboard.
Oh, it is?
Under course documents.
Is it Newton's second law and the linear momentum of a particle not on this?
No, it's not on that. It's old. Sorry, accidental.
Yeah, it's just up to the top.
Just up that line. I'm sorry. This is old. I don't know why it hasn't been fixed. I think it's because I just keep forgetting. Maybe I'll remember right now. We're going to fix that. But thank you, yeah, 100%.
Wow, I did that yesterday. I looked up the equation sheet.
Yeah, look up this equation, print this thing out, and then simulate the exam, right? You'll do much better if you do this. All right, so, okay, so let's get into some problems. I take requests. What kind of problem would you like to do? Want to look back at this list right here and maybe say, was that?
An exam problem?
Preferably question 1, 2, and 3 on the exam.
That's what I'd like to do.
Yeah. Oh, I see, you're making a joke. Sorry, joking around. My head's not in it.
I'll look at one of the old exams.
Okay, look at one of the old exams right there. Okay, so some of the things I picked this one out one time for a I decided I wanted to make this an exam problem, but it was way too long, so I decided against it. But I liked it because it had a bunch of different elements. So this is kind of, by the way, this is more like communicating to you what I do. So I've thought about replacing these practice problems because those were Coast Guard Academy practice problems. There's a couple things you should know. Coast Guard Academy, their classes are 50 minutes long. It says 75. So sometimes we had to, I don't want to say dumb down the problems, but we had to like make the problem, we had want to cover this topic, this topic, this topic. So we might have 5 problems on a 50-minute exam, but we had to make them really kind of a little straightforward. Well, I want to do less problems, but I'm going to ask you 3 separate things maybe within a problem, that you have to know 3 separate things to be able to do it. So here's what I invented, but I rejected because it was way too long. So we could go through this if you'd like, and kind of see it, and kind of see the mindset, like the approach that we have to do. And I think I need to write down on paper, because we're recording this, I need a camera to do it, because I don't want to do it on the board, or I could use this. My office is right over here, so I got you. I got my little clipboard.
That's why I like to be close.
This is being recorded, so you should say something so it does not just hold us like silence on the recording right now.
Hi, YouTube.
So Fridays, they exist.
Wait.
Not really use
camera.
Definitely. And there's
I think you turned the camera off.
My camera.
definitely not that efficient.
Dude, I'm gonna get it cropped out on a YouTube video. I'm gonna go back and I'm gonna look. I'm gonna search.
Crop yourself out, put yourself on Twitter, see if you go viral.
Yeah. You know, I'm gonna say it. Dr. Deal, please put a timestamp when I get the feature in.
I don't think he's ever gonna watch it.
Yeah.
Oh,
I bet anything he doesn't watch it.
okay.
Do you ever watch the recordings?
Do I watch my own recording?
Yeah, no, you just put them up.
Sure.
You watch your own recording?
Yeah, because I'm a narcissist.
I told you he watched his own recording.
Why, is there something wrong with him?
No, I was just confident that you wouldn't watch your own recordings.
No.
If I recorded something, I would just be like, yeah, it's going up.
Yeah, no, sometimes I do, and sometimes I've actually edited?
Edited?
It's a hard word to say, edited. I would edit TED, that's what I do. I have a screen capture program of my own called Camtasia, and what I'll do often, boy, this thing doesn't use enough of the screen. Look at that blank.
I bet you could change the angle that you get.
But I mean, these margins over here that I just don't like. Well, it's actually not too bad. Okay, stop complaining. I'm gonna sit down and do this. But I gotta have.
Do you know where that problem is? So I can pull it up.
Yeah. Well, I wrote it, so probably won't be able to find it.
Oh my God, on your blackboard.
It might be on my blackboard, maybe. I think it might. It's hard to say. Where did it go? Here's old exams. There's a bunch of old exams. This is actually these
one of those
practice
problems?
Here
We
it
just
is.
do one of those. I just want to do a projectile motion.
We will. I swear to you. Okay. So here's one to start with. We said we were going to do it, so let's do this one first, right? So we got this train, the A train, right here, and it's 1.6 kilometers from a crossing right there. So it's 1.6 kilometers right in there, and it's traveling at 130 kilometers per hour when it applies its brakes, and it slows down with a constant deceleration. Its decreased velocity is observed to be 96 kilometers per hour when it reaches 0.8 kilometers away. So like somewhere like halfway through here, we said it went from 130 to 96 right there, right? So it's gone about halfway. A car, this guy right here, this numbskull, he decides he's going to beat the train. So he's going 80 kilometers per hour, and he's 2 kilometers away when he sees that train, right? When he sees it right here where it is. So I'm trying to, it's kind of, overly wordy, but that's okay. If in an unwise effort to beat the train to the crossing, he steps on the gas and accelerates. The angle between these is 60 degrees, so let's say, like right there, okay, you're seeing the theta is right in there. And the car miraculously beats the train by 4 seconds. So what we want to do is we want to find the relative velocity. I decided I got rid of relative acceleration because it took too much time. Of the train with respect to the car when the train passes through the intersection. Provide the magnitude and angle with respect to horizontal indicating quadrant. All right, so there's a lot of stuff going on.
You have to get with respect to, from A to with respect to B.
Yeah, so we want it with the, so we'll read it again. Of the train with respect to the car. So A with respect to B. Yes. A lot of stuff going on, so what we have to do is kind of organize our brain as we're looking through a problem like that during the exam, right? Remember, this is all happening during an exam. So maybe, we don't have to take the time to redraw the thing out, but I swear to you, redrawing things out can really help you. All right, so we have this distance right there is 1.8 kilometers per, and here's another spot right here, which is, I said it was 1.6, dummy, and this was 0.8 kilometers right there. And here's our car B, and he's 2 kilometers away, or kilometers, don't know which, don't care. And so we don't know how fast he's going. Do we know how fast he's going? No, we do. No, his initial one is going to be 80, right? And then his initial one is VA O, let's call it. Make sure I'm on the thing. Is 96? No, he starts out at 130. And then, but when he's right here, which we could call this, let's see, did I number these? No, I didn't, but it'd be a good thing to do. Anyway, when he's right there, his V of A, let's call it, that's 1. Let's call this point 1. We'll call this point 2, right there. But when he's there, he is 96 kilometers per hour. I think we summarized that. And then the only last thing is that these are 60 degrees apart, these two pieces. I could have used a straight edge right there because I had one right there. All right, so the first thing I would do in approaching this is like, I don't know what the acceleration of the train is, but I could figure it out. I might actually, even before I get there, kilometers and hours isn't like our preferred thing to do. We don't have to, but I would prefer to get into meters. So just, I might even write it underneath this right here. Didn't really leave enough room, so I'll just go here. 100 kilometers per hour. In my calculator, I turn into 36.11 meters per second. I turn in 96 kilometers per hour into 26.67 meters per second. And then I turn 80 into 22.22 meters per second.
You gonna need us to do conversions on the test?
No, I probably wouldn't. I mean, this never made it past the prototype stage.
Okay.
So I usually try to.
What is the conversion from?
Okay, well, it's 1,000,
Yeah, obviously.
and then turn to 3,600.
So I have to do 1,000 over 3,600.
I believe so. Yes, yeah. If you multiply this by 1,000 and divide it by 3,600, you would
That's
get.
your answer.
Yeah. Or obviously you could probably just divide it by 3.6, right? And it would be the same thing. You multiply by 1,000. Yeah. Okay. Cool. If my math is hard. All right. So what I would do first is to find the deceleration of the train. Right. So that's one of the steps. So we could say at 1, right, when we're at 1, that train, his velocity, let's call it V1, is going to be equal to the velocity, initial velocity, plus the acceleration times, what, we got to be careful here, we got to go this one and this one, right? Because it's a position thing, not a time thing. We know the position that's changed. So 2 times the acceleration of A, and then we go delta S, whatever, just whatever dimension it's moved, which we happen to know is 0.8, right? So 800 kilometers, 800 meters, excuse me. So we go 26.67 squared plus, no, equals 36.11 squared plus 2, and we're looking for A, looking for that acceleration, and we now know that's gone 800. So that acceleration should be a negative 0.3704 meters per second squared. And pretty much our mindset was, well, let's just do that because it's something we didn't know, but we kind of we could read into the problem, right? We kind of infer like, that's something that's going to be useful to us. And now we might want to, now knowing this, we're going to be able to find the time when he gets to the intersection.
Because we have a distance to the intersection.
Because we have a distance to the intersection, so we'll be able to figure out what time. Because we know this time is really the linking thing that's taking place here, right? So t equals when, t is at 2, I guess. At 2, when does that happen? Well, so we all we need is a distance, let's say that x has traveled right here, between 1 and 2. It's going to be the, I guess maybe I'll write it out the right way, right? So,
Don't you need the velocity?
we only know the initial velocity. We can get the velocity too, if we want to. But it might be easier to just get the time first. We could get the velocity as well. We could do it either way. If you'd like to, we could get the velocity then. But I think the time is going to help us. But you might be right. We might actually have be better going that way. I don't know. Let's take a look. Let's see how things are going. So we have the velocity of A initially times the time plus 1/2 times the acceleration of A and the t squared. So we could say that, all right, well, this is going to be our 1,600 equals, we'll say that starts at 0 plus our 36.11 times our time plus 1/2 and then minus 0.3704 and then a t squared. And then we do our quadratic equation thingy, and we would find that the time when that happens, I'm just gonna jump ahead. Is that okay? You could, yes, hello? Hey, how are you? Oh, I just turned my head away to see. I think it's James. Almost sure. We get the two roots that we get from this, because it's a quadratic onto the thing, ends up being, where'd you go? Oh, there's actually two separate things to try. 68.09 seconds and actually 126.9 seconds. So we need the time because we were told in the problem that this guy gets to, is like over here at point, let's call him point 3. I guess I need to move that up. I call this point 3 right here, that this right here took place delta 4 seconds, right? So he has passed over to here. So when the train gets right to here at 2, this car is here at 3. Does that make sense from the narrative of the thing, of the story? So what I'm going to say is that I've selected this time right here as being the one that's more appropriate. I'm not sure what I actually later on went back and tried, and I saw that I'm not really sure what the physical meaning of this one was. I was expecting a negative as one of my responses, so I'm not quite. I'm trying to figure out what that was, but once again, I invented the problem. So although I modified it because there was another problem, but the problem didn't have some of these elements in it when I created. So anyway, so the time at for the car, let's call him B at 2, right? So this is really kind of be A at 2. That's what we just solved for. So he's going to be 68.09 minus 4. So 64.09 seconds. And so what we're going to be able to do is figure out his deceleration, right? Because he started out delta x. What, excuse me?
You're going to figure out the car's acceleration.
Acceleration. Did I say deceleration? I'm sorry. Yeah, he's going in it. So he's going delta xb. I just put that back over there. Is I guess I got rid of the delta. Eraser fell off. All right, okay. We'll say xb where he starts plus vbo where he started plus 1/2 acceleration of b times t squared. So he's going to be traveling, what, 2,000 meters? Because he was two kilometers away. Let's take that as 0. We said he's starting out at 80 kilometers per hour, which we said was 22.22 meters per second. And the number of seconds was 64.09. And 1/2. And we're looking for the acceleration. And now it's 64.09 squared. So acceleration of B is going to be 0.2804 meters per second squared. Certainly, he must have been able to accelerate more than that, but that's how this thing turns out to be. So now we have these accelerations, right? We can go back and, as you mentioned, we can find the velocities for both of them. Actually, now I got to think about. Oh, I see. Okay, now we need to know the velocities when A is at 2 and B is at 3, right? Because we want to know the relative velocities at that point. We're going to assume that he's going to keep on accelerating those 4 seconds, even though he doesn't have to. It's a terrible story. Anyway. So we continue on down here. Let's see. Okay. When A is at 2, velocity of A, or the speed of A, is its original plus its acceleration times its time, right? Times that time A2 right there. So he starts out at 36.11 with a negative 0.3704 and 68.09. And for some reason, I think I have the wrong numbers for some reason. So let me check my numbers with my portable. See, I got the portable free Hewlett-Packard calculator. You don't care. 36.11 and 68.09, and take a 0.3704 times but minus. Yep, I have it written down wrong. So 10.89 meters per second. But VB, and I guess this is VB at 3, and this is VA at 2, right there. VBO plus AB times T. Now this is at that time when A is at the intersection. So we're starting.
Can I say the problem again? I'm just confused as to what you're finding right now.
Okay.
There was no problem, like a second.
No problem. No problem.
What are you finding right now?
Okay, I am fine. Okay, so we want to find the relative velocity of the train with respect to the car when the train passes through the intersection.
Okay, so at the point, so when they both have traveled the time of 68.
Yes, exactly.
Okay, I was just confused as to
Gotcha.
what
Okay. I totally no. That's why we're doing the problem, because it's confusing, right? We're trying to make, pick the thing apart and try to work our way through logically on how we get to solving something that's fresh to us. The first time we're looking at it and trying to think our way through, trying to make a story. It's those word problems that started out in 5th grade or whatever they were that you hated. Life is a word problem, right? So we're stuck with it, but but that's how you pick the thing apart. But I try to make them real. I tried to make this a real thing. Because, these are things that you could actually measure with a stopwatch.
A dumbass going through an intersection.
Yeah. Maybe this is a court case where, he just, God forbid, hit a dog or something right over there. You're like, okay, I know. I just made it. We went dark.
That's terrible.
We went dark real quick, okay?
Why?
Well, I'm trying to go motivated. We're going to try. We're the prosecution. We're a witness for the prosecution. We're trying to find out, how fast is this moron going? Well, we clocked him doing this, right, in this one spot, and now we're going to try to see, well, how much was he accelerating? I don't know. Anyway, it's just a story. I just came up with a story. Now I'm sorry. I apologize. It wasn't a dog. It was a kid. Oh, that's even worse. Sorry. Let's go back in. For points, yeah.
Why is the relative
Death rate's
velocity
2,000.
per court? I understand what the velocity matters, but the relative velocity.
Okay.
We got
So
Because it was the guy
we've
on
gone
the
way off
street.
topic.
It doesn't matter at all, it's simple
I
property.
don't like relative.
I don't like
Because we're
this.
talking physics here, the dead thing doesn't matter.
41.31 meters per second, right there, right? So these are the two speeds that we get in this constant acceleration problem. But now we want to get the relative velocities to these things, right? So what we have, it's always helpful to make these triangles on things, and I'll keep it onto the pad here because I have it. By the way, this is the next generation of those rulers. I was thinking of giving out these, except they're fragile as can be, man. They're just as brittle as can be. So
Crazy ruler.
look at that. It's got it's like a drafting piece of art there. Okay. So what we're trying to find is find. Sometimes that's good right there. Find the velocity of the train with respect to the car. So A with respect to B. So when doing something like that, there's always, for me at least, I want to find and draw a triangle. I say, well, that's going to mean that I'm going to find A equals VB plus VA with respect to B, right? So that's when I'm drawing my triangle, that helps me. And so we're going to try to find, this is VA right here. And so we're going to add to find this, we're going to take VB, which we know is going to be up that direction right here. And so when that happens, we have to do this right here, right? So this is going to be VB, and this is going to be V.
From the base of A.
A with respect to B, yeah, because it has to go,
That's what
these guys and this right there, right? That triangle, making that triangle helps me to think through and make sure that I'm going to get the thing that I want. But of course, obviously, what we want to do here is we could either do this by using law of sines, law of cosines, because we have this, we know this, and we know that. So we use law of cosines to find this if we wanted to. And then we can use the law of sines to find some, these, the other angles. That's one option, but it might be easier to do components. Because this one the A only has one component. So all we need to do now is break VB into components. So VB is, I don't have enough room. I guess I keep writing on people use more papers, so I probably ought to not be a hypocrite. But I haven't gone through yet and told you why hypocrisy is a necessary human trait. We can't live without hypocrisy.
Why?
We need it. Because we would just devolve. Like, if nobody could ever tell somebody not to do something because they had been guilty of it at some point, then we would just have the lowest nobody would ever tell anybody not to do something because everybody had been guilty. And who better knows what not to do than people who do it?
So should we just listen to people who've done things wrong?
You should listen to everybody. You should just listen to me. That's all you should listen.
That's the point.
My kid's really sick of
That's
that
the point of
about that
listening.
whole thing. And then they go, Dad, you're a hypocrite. I'm like, exactly. Do as I say, not as I do. All right. We've gone off track again. Yeah, that's what track, because we're doing a train track thing. Okay.
So we're back on track.
We're back on track. You're right. I stand corrected. Sit. So let's see. That's going to be 60 degrees right there too, right? So we're going to take in the cosine of 60 degrees. I plus 41.31 sine of 60 degrees. J.
What is that?
That was the noise because I had logged into Collaborate. When you don't do anything in Collaborate for a while, it goes, "Are you still there?"
No,
It misses you, and I'd say, no, I'm not there. Leave me alone. Go away. 41.31, enter, 60 cosine times 20.66 I, and then flip them around, and we got, go 60 sine, shouldn't that be like 0.5? Nope, that's the other one, right? Boom. 35.78 J. These are meters per second.
How is there a J velocity?
B's going up.
Car.
It's B, right?
Oh,
So
it's B, so A doesn't have a J velocity.
A doesn't, right? So
And
when we
that's
go
why it was just
V,
for a second.
A with respect to B, you remember that's VA minus VB. Give them all hats.
Everyone gets a hat.
And then, we're off the screen, sorry. So A is, they just kicked us off Collaborate. A is gonna be the 10.89, and you're gonna have a minus. Okay, so the way I drew this right here was not proportional. It's probably gonna be like way the hell over to this part right here, because VB is so much larger than VA. So but that's okay. That information is useful to us. So we're gonna have 20.66, right? And then this is just gonna be negative 35.78 J, right? And it makes sense because it's, going back that way, at least this from the triangle point of view. So,
And that's the answer. I understand.
yeah.
But I also understand this shouldn't be a test question.
Well, it seemed at the time like it was gonna be like, okay, this was a good candidate, but it just took so much
Are
time.
you gonna use relative things, like with respect to,
What do you mean?
like on the test, are we gonna have to use both, like find the velocity of something with respect to something else?
Well, sometimes I do. I haven't written it yet. I don't know.
Oh, I don't like that stuff.
I'm sorry.
When's the exam?
But anyway,
Tuesday. It's Tuesday.
so we take the square root of these. I'm off again. Yeah, you're gonna have to keep reminding me. It's an occupational hazard. They don't look right. Let's see. Oh, that don't look right either. Shoot. No, maybe no. I think it's right. Okay. I don't know. The numbers are probably wrong. I feel as though I made a mistake. but yeah, so 35.78, 9.766. Remember, always remember this, please just trust me in this. I am not out to try to see how low your grade can be. That is not my mission. My mission is to extract from you whether you are, whether this stuff is sinking in, and your problem solving skills. How are your problem solving skills, and some of just the kinds of things that somebody that says, hey, did you go to University of Hartford and take a dynamics class? You said, well, yes, I did, with Dr. Deal. Well, are you able to do this? I'm like, well, he never told us how to do that. And then, okay, well, shoot. I don't know if I like this. It's got to be in that quadrant, right? That way and that way. Yeah, okay, that's fine. Yep, 74.73. Wow. This is going to be a really, this triangle is going to be really ugly. So like a real triangle of this would be like crazy ugly. I think it's going to be something along the lines of, here is that little tiny guy right here, but then like, and you could, by the way, with the, maybe we'll use one of the, there you go, here's yours authentic one. We could actually do this as, right here, here's like, here we'll call that 10, right there, so that's 10 millimeters or 1 centimeter right there, right? So that represents the speed of this guy. We'll make it 11 right there, right? So that guy's like 10.89. And if the next question is that you're going to ask is, will I make you do it graphically? Boy, I really would like to, but I'm not gonna. But I would like to. That would be my thing. That's my game, right? That's what they. But anyway, let's see this right here. Actually, it's not too bad, right? So that's going to be something along the lines. Well, we could actually do the angle. With this, we could actually get the angle, right? So that's going to be. Let's see if I'm going to use this thing correctly. Let's see, I'll flip it back over. I didn't know that it was going to be here. So like right in, that's 76, something like that. Like we could go, well, it's kind of hard to see. It's going to be like that, more like that right there. Something along those lines. So that angle right there is going to be the 74, right? And then so from this, let's see, what did it say? It was like 37 while he was using these. So 37, something like that, right? So right there and right there. So right here is the VB, here's the VA, and here's the A with respect to B?
Yeah.
Yeah, A with respect to B, yeah. So I probably could have used a different scale on there just to make it a little bit bigger, but you get the idea. That was the nature of it. I know. It was a longer problem than was possible to do during an exam, so I was like, I wrote on it. Much too long. Even getting rid of the relative acceleration onto the thing.
Can we do one of the old exam problems though?
Sure. Now this is old. Remember, these are old exam problems from.
You don't have like last semester's dynamics exam one?
Well, I try to keep them from you, but let's see. I'll do this one.
That's like
All right.
a good help.
It's not going to be the same one, so it doesn't.
Still.
But I like to keep them for posterity.
So what's the difference in a coordinate transformation between path and polar coordinates?
There's no real difference except for in a polar situation, quite often, you're almost always going to have, well, you will always have, the E theta is always going to be to the left of this, to the left of ER. Whereas you could have, see, I'm going to do this the wrong way. No, I'll do it right here. Right here could be our tangent, or right here could be our tangent. But the normal is going to be this way, whereas the normal is going to be this way, right? So that's one big difference. It'll flip over,
Okay.
right? This is to the left of it, but this one is, you could think of that as being, the normal could be to the right. It depends on the curvature.
Okay.
So that has a little bit of a difference between that, but functionally everything else is kind of the same thing.
Okay.
So path is set in one spot and polar moves relatively to where you are.
Well, okay, so not necessarily. You might. I'm gonna let me do this example right here. You requested a problem from a previous year here at the University of Hartford. So I'm gonna give you last spring. Was this last spring?
Thank you.
But I ain't giving you a lot of them.
Let's talk.
Just okay. So this past spring, I had this problem right here. All right. So by the way, look at, see, I went this is my process. You can see at the top, this is the first problem here. So I measured mine, and I said it took me 10 and a half minutes to do this, 5 minutes to do this, and 10 and a half minutes to do this one. So I decided that's how I was going to break down the score. You see I get a total of 26 minutes. And I try not to go really fast when I do myself. I try to.
You could even go faster than that?
Yeah. Probably get things wrong, but I could go faster. I just try to take a nice even pace onto the thing. Okay, so one of the things I see students do all the time that I wish I could stop you from doing. I could coach you to stop doing it. They'll sit there and they'll look, people right here won't be able to sit, they'll go. What is that accomplishing?
Thinking.
No, think this way, think with your hand moving.
Think with your.
Think and keep going. That's where all the time goes away when you're not doing something. And you know how you do? You got to practice still. You got to practice. Make this thing, the motion of getting the thing as you're going through and you're writing the thing. Think about the next thing that you're going to do.
So many things.
I know, but it's just the test-taking skill set. It's that, that it's great to be a slow, methodical thinker in the non-test environment, but it don't help you, right? So, I mean, it's definitely an acquired thing, but it is doable, that you can get better and better at it. Not perfection, but I would say that there's a lot of people that just, will excessively think. Yeah, take a moment to think, but and I might be exaggerating that you're writing all the time, but I've watched people just getting frustrated. And also, I think I'm a nice guy, but I'm sure lots of bad people think the same thing about themselves, so I don't know. But if a student comes to me and asks me a question during an exam, I'll try to nudge them in the right direction. I don't want to answer their question directly, unless they just keep asking me. I don't say, no, don't do it, all right? But don't go to the extremes, right? Don't sit there in misery, wasting your time, going, I have no idea what to do. I would go, well, did you notice that? And I went, I don't get it. And then they'll say, where's your equation sheet? I'm like, here, what about that thing where it is? How does that apply? And hopefully they'll go, well, oh, and they'll go back to their seat and they'll get out of their rut. I can't stop myself. I'm a nice person. But at the same time, if you have no idea what you're doing, that might not be helpful to you. But just saying. Don't waste time being in misery. All right, so here is the scenario here. Instead of watching the Super Bowl, UHart Dynamics students are trying out a new camera that can track flying objects with great accuracy. Using the test setup shown, here's a little camera thing going right here. There's a football, for whatever reason, it's getting shot out from right here, flying through the air and landing from here. So starting at A, it's going to B. So what we have done here is I'm making a projectile motion problem combined with a polar coordinates problem. This is a polar coordinates problem that's with the origin right here at that camera, and that camera is going to move and follow. It's going to track, it's got like some kind of radar, magic radar it can fly there, right? So the football gets launched with an initial velocity v0 with an angle of beta, so that angle right there, measured from horizontal. The ball lands at point B, t seconds later. So I've given you the data later down here. And spoiler alert, I give out list 2 or 3 versions of the exam sometimes, so that people can't copy off of each other. And not so that I'm trying to catch you, but just so now there's just a deterrent, right? Don't bother, don't try. Because it'd be tempting, could be tempting, after it's released. The dimensions A and B, let's see, where did I put them? A and B haven't been measured, but the flight time is sufficient to determine them. Okay, so I'm telling you, I didn't give you that and I didn't give you that, but you can figure it out from what I'm telling you, the time that it has landed. So determine the polar coordinate variables of interest, r dot and theta dot, just before the ball lands. You must perform a coordinate transformation as part of the solution to this problem, right? So I've combined 2 things. Got projectile motion and polar coordinates. That is more typical than the Coast Guard ones. The Coast Guard ones, I generally didn't do that because, well, we were teaching by committee, by the way. Everybody would write a different problem during the thing, and because we'd have like 4 sections of dynamics. Sometimes we'd have 4 instructors, which was very inefficient, but we would like coordinate with each other and write the exams together. So some of those were written by other professors, not me, right, during my time there. So let's start out with the stuff that we know, kind of summarize it down there. Maybe I'll re-sketch the thing out, and I'm not saying that you should re-sketch the thing out, but it does help me, right? So that's sort of like, maybe it's because I like to draw. That's my method of doing stuff, but I have found it to be useful to kind of like think my way through a problem. So we're shooting this football, beep, 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 boom, and it lands, boom, right here. And we don't know this A, and we don't know this B. Do we know C? Yeah, we are given a C, right? So the camera is actually like right up here. He's right above the thing, and he's tracking it, so we are given C. And that VO that we're given is 33 feet per second. The beta that we're given is 42 degrees. Right here, so here's beta. Here's our VO. C, we were told that it's 4 feet, and the time is 4.5 seconds. So immediately, we want to try to get stuff done. We want to keep moving. Don't stall, right? We want to have our test-taking momentum. We have a lot of inertia, a lot of metaphors going on here, but get things on paper. VXO is equal to VO times the cosine of beta. So 33 times cosine 42 equals, right? Getting partial credit all over the place. Boom. Couldn't possibly get a 0 on this exam because we just wrote down a couple chunks of information. Boom. Right? So at least you know that we had to do this. And I guess we'll put units on there, feet per second. I got it off the page, sorry. VY. (33 sine). And so we have what, 42, take the sine, take 33, boom. So we had 22.08 feet per second. I should see if I make any mistakes. I gotta put my page to the side. Next, I want to try to start thinking about, where is this ball? Like how far has it gone? Well, let me try to figure out where. I think I mislabeled it. I think this was A and this was B. Sorry, this was A and this was B. Let me try to find where A is. Well, if you know, what can we use, right? It's a constant velocity problem in the x direction. So I can figure out A. I can figure out this distance because it's the same velocity and we know this time. So we could find that A is equal to x is equal to its original position plus its velocity in the x direction times time. Starts out at 0. Let's call this the spot, or at least over here. Let's actually call this a 0 right there. That's the origin. Plus our 20. Did we do 24? Yeah, 24.52. And times 4.5 seconds. And we worked that through, and that should be 110.4 feet. Now we can do this thing in the y direction. And so we're going to be able to get where B is. We're going to be able to get where B is, because that's going to be the initial thing. So, no, let me think. Yeah. So where B is going to be equal to, yes. We'll find out where y is by taking its initial position. And so we're going to assume that this is where? Up there at the top right there. That's the initial position. So we're expecting it to be a negative number, by the way, because we're measuring from that position downwards. So we'll start out with VYO times T plus, really should be minus, right? Minus 1/2 G times T squared. So, get the 0 there, plus 22.08 times our 4.5 minus 1/2. And remember, it's system of units, this is going to be 32.2 because it's US units. People do make that mistake all the time. 4.5 squared, and so that's going to be equal to, I think it's an astounding, this is a bigger number than I expected. I even put 3 exclamation points, that's a lot, next to it to go 226.7 feet. I might have changed on the actual exam because but this was my prototype run through for the thing, because that's a lot. It's probably because my beta was pretty, I don't know. But anyway, so the thing drops, and so now with this, we can find out what its velocity is going to be when it hits the ground, right? So we want to determine the polar coordinate variables just before the ball lands. Remember, that's what the thing we're looking for. So in our goal set is to find the velocity right here. Yes, sir.
How did that determine the original height?
Say again?
Oh, I see that.
Okay. That's all right. So we want to find its velocity just before it lands. So the easiest way is to go, this equation right here. And we don't use this equation a lot, but this is going to be the most straightforward way, the quickest way to get this velocity, that velocity at the end, right? You agree with that? Sure. So we start out with this was 22.08 and minus 32.2. Wait, did I do something wrong? No, we could have got this anyway. Yeah, we could have got this anyway. I see what, yeah, I remember now. So we could have found this velocity without having, it wasn't dependent on those other things. But it's just something else that we do. We get it as a negative 122.8 feet per second. Now, what we really need we have a lot of the stuff set up. Now we need to start going into the polar coordinates kind of idea. So first off, looking up at our original spot right there, it's actually going to be looking downwards, right? So it's over to here. It's from the camera to the spot is going to be the R for our polar coordinates. Does that make sense?
Why from the camera, not from the ball?
Because the camera is the thing that's measuring the ball.
We would then have to determine the angle between the camera and the horizontal.
Yep, and that's why we got these dimensions.
Can you just show the question again one more time?
Okay.
I'm sorry, everyone else.
No, it's fine. Let me see if I can get that to be a little bit better focused. So what we want to determine the polar of variable of interest, r dot and theta dot of this camera, right? So this camera, it might have, maybe I needed to write the question a little bit better to make it 100%, you know, interesting or usable, right? So you can just picture the camera can pivot this way, right? So it's like maybe it's rotating, its theta is kind of going that way as it's looking down at the thing, right? So it's so
The
it's
camera's stationary, right?
the camera's stationary, but has a little motor on it, so it can
It just goes up.
it can follow. Yeah, it can follow along. And so we want to figure out how far away that this perception of the motion of the football is going to be. I was trying to make a football relevant thing because the Super Bowl was like the next day.
Okay, so I get it, because now we have the height of the camera, we can find the height from the camera to the ball.
Yep,
and
yep,
everything
yep,
relative to that.
Exactly. Yep.
Okay,
So
I was just confused.
yep. So we're gonna be able to find this theta and this r based on we found A and we found B. Now we just need to add C to B, and so that we're gonna get r is equal to the square root of, let's call it A squared plus B plus C squared, right? So we'll say the A was going to be 110.4 feet, and then the B we found to be 226.7. Doesn't matter that it's negative here, we're just trying to find that height, the original height, and we added 4 to it. So we end up with an R of 255.7 feet. And then we have a theta. We'll take the inverse tan of that same thing, and it would have been, so here was the rise right here was the B plus C. So that was the 226.7 plus 4. Might have saved us a moment to have found out what that number was, but not much. And anyway, that ended up being 64.43 degrees. Oops, sorry.
I just have a quick question.
Yes, sir.
So when calculating the angle, it also doesn't matter that 226?
No.
Or
I
are we
prefer not to play around with the positive and negatives within the tangent.
Or I was gonna say, are we making that height positive because we're setting the origin at that bottom left corner?
No, I'm doing it just out of convenience and habit.
Okay.
Is that I know I want to get that angle right there, so I know it's going to be in that the bottom, the fourth quadrant. So I don't need to go positives and negatives within my inverse tangent.
Okay.
Because I already know what quadrant it's going to be, so I don't need the calculator to try to tell me. Because a lot of times it'll give me something that's an angle that's greater than 90 degrees. And I'm like, oh no, I got to try to figure that out. So I just systematically I'll go about with that. Okay, so now I want to do my coordinate transformation. So I'm going to set up my, systematically always have this I and this J right there. Draw that first, and now I start thinking about what does my R look like? Okay, well it's going to be this direction down there, my ER. And always pointed to the left of the ER, so that means that the E theta goes up this way. And looking at my diagram, I know that my theta was that way. You okay with that? And like I said before, I like these just to make me feel better. Just putting those things in there. I guess I didn't extend him yet. So to make my coordinate transformation array, here's my I and my J. Here's my ER, here's my E theta. So looking at this for the R and the I I see that I have a cosine,
Positive cosine,
positive cosine, yes.
then negative sine.
And now I need a negative sign for the j, because I've dropped down below. Then I say for my E theta,
Positive sine.
I agree, positive sign
Positive cosine.
and a positive cosine. So for my VB, for the ball, I could have done this, I could have done these in any order right here, but I have the X I know is constant, so that the initial is 24.52 I, and the final, that was the negative 122, right? Feet per second. So I just have to apply my VB. And I think I have the wrong numbers because I just crossed, I showed them as being crossed out. So let's try to get it right this time. So we're going to take,
Just finding velocity.
yeah, we're just finding the velocity into this. So we have two parts to it, so we have to go, let's go for I first. So we're going to go, no, let's go ER first, I'm sorry, ER first. So we go 24.52 from the I times this ER. And so the cosine of the 64.43. And then we're going to take the J of this, so go plus, but we have a negative 122.7. And then we're also going to go times the negative sine of 64.43. And that's all. I'm sorry I squeezed this in there. I made a mistake by not moving over to the left some. That's all ER. And then plus this one, now we're going to go down to the E theta. It's going to be 24.52 times the sine of 64.43 plus negative 122.7 times the positive cosine of 64.43. And that should be the E theta. So I have some crossouts here, so I don't think I have the right numbers. So we'll go 64.43, enter. So I have the stack full of that, and so I'm going to go cosine 24.52 times, and then flop that around, and I'm going to have sine of that one times 122.7, boom. And that's a negative, so they should add together. So that should be 121.3. And then flop them around, and I'll go enter. And I go sine, where'd you go sine? Times 24.52, boom. And flop them around and go 122. Whoop, nope. Coming down, okay. Well, we'll go cosine of that. And then 122.7 times, but now that's going to be subtracted out of there. And I'm going to get a negative 30.78. So we can rewrite our vector and use a hat. It's like men back in the day would never leave the house without a hat. Isn't that weird? Really? Very obsessed. The man came in bareheaded. Can't believe he came into our store without wearing a hat. People would be offended by that kind of thing. Weirdos. Okay, so we know that R dot from this is going to be equal to 121.3 feet per second, right? That's one of the things we wanted. And the other one, we know that this guy right here is gonna be r theta dot. So all we have to do to get theta dot is gonna be have that, we'll call it that component, that the v theta divided by r. So
R is 255.75.
did I? No, okay. Yes, 255. And so 255.75. So we get a small number, but it's a negative 0.1204 radians per second. So those are our two. Those are the answers that we're looking for. And the problem is too long if I tried to ask for the acceleration one, right? It's just going to take us too much time. But we could do it. But I think if you could demonstrate that you could do this, you could demonstrate that you could do the other. So, from my point of view, that's good enough. Did you get the gist of the kind of problem that you might get asked? Yeah.
R. R is the original.
No, I know. Oh, okay, never mind.
Good.
I found it.
See, that's
I
almost.
thought I didn't write it down, I wrote it down.
R is the original.
Okay.
Yeah, and then so last spring, the next problem I asked was a path. Okay, so I guess I'll burn this entire exam. We'll burn.
I want to get a drink, I'll be right back.
Okay. So I decided to try
The
to.
one we hit in theta.
Any other buildings?
So I tried to combine in this problem doing path coordinates and also doing fundamental kinematic problem, right? So that we had to do something that this was a function of time. Velocity is a function of time. So I thought about, sometimes I like to do the position, but then it gets a little hairy. I decided this is what I want. So a new UHart electric motorcycle design.
Thank you.
Thank you, sir. Has a speed characteristic that is a function of time for some reason. And following this, you can see characteristic form of right here is 2 times time plus 0.1 times time squared, where v is in meters per second and t is in seconds. It starts from point A, right here, from rest at point A on the track with a diameter d. Right, so I gave you d right here. Determine the distance, delta s, the motorcycle has traveled and the magnitude of its total acceleration after t has elapsed. So the basic idea there is I'm trying to see if you can, and it was actually it's a really short problem when everything was said and done, because, but of course it doesn't seem that way sometimes, right? So you're traveling from here to maybe over here somehow, and we really want to find this distance right here, this arc distance delta s that we're traveling on here, and it's got a diameter d, and so that diameter is 800 meters, and the time is 10 seconds, and the velocity is a function of time, is going to be 2 times time plus 0.1 times t squared. So anytime we have the velocity is, we need, okay, so what we're being asked to find delta s, and it says total acceleration, so that means both the tangential and the normal acceleration. Find the magnitude of them, right? So I'm just trying the magnitude of the acceleration. So we know from that we're going to need to have tangential and have normal. So from this equation, we have to take the derivative of it to get the acceleration, but we also need to find the position, so we have to take the integral of it as well. So I tried to find one way I had to take the integration and the derivation. So let's first find the derivative of it, because that's pretty easy.
Is that equation given in the question?
Yes, this equation is given in the question. It's some imaginary electrical bike that can do this for some stupid reason.
Magic bike.
It's a magic bike.
Cool bike.
Yeah, that's what electricity is.
Electricity is a magic bike.
It's just magic.
Electricity is just magic.
It's PFM actually.
What's PFM?
Pure magic, and you can guess what the.
I got it, I got it.
You can guess that's what electricity is. That's why I'm not an electrical engineer. I can't get my head around them funny little electrons dancing around. I enjoy being dumb on purpose. All right, so anyway, take the derivative of this. We could just write that down. We don't need to think about it. 0.2 times t, right? Did I get that right? I hope so.
You did.
So we could actually even find this answer right here. We don't have to wait. So I do believe that the answer is 4. So that's going to be the tangential one, right? That's going to be equal to the tangential because that's what he's doing in line of the curve, right? So you could think of that as the AT coming that way. But he's also going to have an AN going towards the middle. So we could even, well, no, we need the velocity to find that, right? Because we need this one, and it's going to be v squared over rho. So we could actually just go ahead and find what the velocity is. So this is v, let's see, come on, get your head in. Too much celebrating last night. We could find out what that velocity is by taking 2 times 10 plus 0.2 times 10. No, not 0.2, 0.1, sorry. Original equation is 0.1. So. And so what does he turn out to be?
I got 30 meters per second.
That sounds right. And look at me trying to be like all like siggy figgies all the time, like adding the extra zeros. I don't care. I don't really care. I'm just trying to be a good role model.
I understand.
Accept my hypocrisy. That part. Don't be like.
So don't follow the bad, just follow the good.
Yes, exactly right. That's what I'm saying. That's what I say. But we could actually find what the normal. We could actually just solve this part of it right now. We could actually solve the for this part of it right there right away. Because we could also now that we have this, we could, I don't know. This is the greatest spot to put it here, but we could go 30 squared divided by our 800, and where'd you go, buddy? You went 2 point.
1.125.
That's how they get you though. Gotta make sure it's the radius. I gave you the diameter.
Oh damn.
It's just a hinky-dinky little point, but you know. Just say, hey, are you paying attention to details? That's part of the mastery.
I didn't read the question.
And the question wants for the total acceleration. So that's going to be AT squared plus AN squared, the magnitude. So square root of 4 squared plus 2.250 squared, and that ends up being 4.589 meters per second squared. So we solved that one, but I also wanted to find delta S. So now we have to actually come back to the thing that we had started up with and find out what position is. So we remember that velocity is equal to, let's call it ds dt. So
just gotta take the integral of the velocity equation.
Yeah. So we say ds is equal to v dt. And we could guess, I guess we go this right here. So we know that's just going to be delta s on the other side. We're going to take the integral of, I like to make it a bracket sometimes, 2t plus 0.1 t squared dt, ends up being, where'd you go? T squared plus 0.1 over 3 t cubed, going from 0 to 10 seconds, and plugging those back in there, we end up getting 133.3 meters. So our answer is 130s, 133 point. That's good enough. Nah, 1.3 meters. All right. But that was my goal. You see my goal, my mindset, combine two things. Didn't have to do a coordinate transformation. Because you already did that in the first problem, so I don't need to make you do it twice.
Yeah, that's a quick problem. Is there usually one quick
This
problem?
this took me 5 minutes.
Is there one quicker problem?
I try not to make 3 long problems, but it's tough. It is a really hard to rate.
I mean, the homework
And
questions are all
exams.
pretty long.
They're very long.
Is a homework question generally harder than a test question?
I try to, but you wouldn't believe that by way of some testimonials. Some people they'll be like, sometimes on my course evaluation, like the exam was so much harder than the homework was, and I'm like, I don't think so. But
Because you get stupid when you look at the test.
yeah, it's a perception thing, I think. But all right, whatever. Here's an exam from. Yeah, this is the same exam right here. So the third problem was a relative motion problem with a, because I hadn't had a relative motion problem, right? So I have a dependent motion and a relative motion problem together. With respect to. Using the block and pulley system shown, a UHart ES143 project team controls the motion of block B for some reason, so that it starts from rest and moves downward at a constant acceleration b. Determine the relative velocity of block C with respect to block A, so therefore we're looking for VC with respect to A, after block A has moved up delta YA. Provide magnitude, direction, and quadrant for your answer. Additionally, draw the velocity vector triangle labeled and approximately to scale of C with respect to A, the same thing, to confirm your results. So I said, okay, so like looking at the setup of this thing and redrawing it, we have A, here's A, and he's got a pulley right here, and he's got a cord attached and a cord attached, and this one goes up to this pulley, and of course this cord goes attached right there. This cord comes up, goes around this guy, and he comes back down, and he's into, so this is the block B, and he comes back up, and he attaches to the ceiling, he attaches to the ceiling, he attaches to the ceiling, here's the ceiling. And let's see, this one comes up, and just to make it go over to the side for no apparent reason, but because I wanted to. All right, so this one comes down, and then it starts to attach to some kind of weird little thingy here. Boom, boom, boom. And he's underneath it, and he goes up to a block. Looks like this right here. Boom, boom. Out go the lights. And he's sliding on this thing. And he is C. So, and we're given that we know acceleration of B is 2.5 feet per second squared. By the way, let's see this angle right here. I need to get that angle. So we're given that angle as 25 degrees. And I'll go at delta YA is equal to 3.5 feet. So when A has moved this way and he's moved up, when he's moved up that amount, we know B is this amount. Is that true? Let me read it again. I'm starting to question myself. Determine the, okay. Okay. Oh, no, this is constant. Yeah, this is constant, okay. Duh. All right.
So acceleration of B is constant.
Yeah, so if the, but because the acceleration of B is constant, all the other accelerations have to be constant too, because they're all dependent on each other. And there's only one rope. That's a good thing to note, right? Make sure that there's one rope. Otherwise, there'd be two different equations to carry. So, good thing to do is find ourselves a datum. And so here's a datum that's going to go, I guess I said go S's on my page, so I'm going to stick with S's. There's SB from here, and here's SA, and then call this one here SC. So that the length is going to be, looks like 2 SB plus, double check it here, 1, 2, 3, 4 SAs, and then plus an SC. So we take the time derivative of those, and we get 0 equals 2 VB plus 4 VA plus VC. Wait a minute. I fucked something up. My bad. I'm sorry. I did.
Why would it be 5 SA? No, there is space between.
There's space between here. See, these are separate cables.
Oh.
Yeah, I went too fast.
Wait, can you go to the problem again?
Yeah.
I want to read the problem again. Where's the 2 givens? Oh, that's why I just didn't look there. I was too busy reading the problem. So it goes down. Is AB negative?
Say one second. When block A has moved up, so this is up.
No, but it says it moves downward at the constant acceleration AB, which means it should be negative 2.5.
Yeah, I guess you could say that, but it says downward right here. This is just the it doesn't have a hat on it, so it's just a magnitude of the thing. You could think of it that way if you want to. Maybe I should have put a negative. I don't know. But you could also we'd also say that like it's a constant, right? So if it's moving in that direction, we could also see that how B and A are related to each other. One goes up, one goes down. So if I said things move down, then you know it has to be a negative. Yeah. All right, so there's actually L1, let's call this line 1, and this line 2. It's because my drawing wasn't good enough that I forgot that it was 2 different cables. That's my excuse for this. That's what I'm going to stick with. So we have 2SB plus SA. And I'll do this over here. L2 is going to be 1, 2, 3, 3SA plus SC. So now I take the derivative of 2VB plus VA, and then take the derivative of this was 3VA plus VC. Take the derivative of these.
I have a question.
There's still space that we're not accounting for.
Why is that rope Cause you have 3 essay, why is that last one not included?
This 1, 2, 3, right?
And the
Yeah,
one-
then the one over.
This
You're
one?
missing a whole chunk of space between the,
Yeah,
at the top,
so
go up,
see the
with
C
the-
and
there,
then you go
from
up.
there to there, and the end down
Yeah,
is
that
all
one.
not included.
Because they never move, right? This length never changes.
Wait,
The length between here and here never changes.
Oh, okay.
Is it because they don't bolt it to
Yeah.
objects that don't move?
Yeah, obviously they don't move. We only count rope that changes length.
Okay.
Because all the rest we lump over to the other side, just like the stuff over on the top of the pulley, in between thing, you know, like in between here and here, that never moves. So we're able to get rid of some things that are constants. Because we don't really care about these equations, we care about these ones below.
and do we assume the distances given are from the datums we find? Like if you give us, say, if you said that the length of the rope from the top to B was
Yeah,
30 feet.
but I wouldn't ask that kind of question where you needed the lengths. If I did, that would be like a mean, cruel thing, because you wouldn't actually
This
know
question
them.
seems pretty mean.
You think this is mean?
Yeah, no, yeah, I would say this is a hard
It's-
question for what we've learned so far. This would be a very difficult question.
Really? I guess it's just the number. Do we have 3? We only had 2 pulley problems, huh? That's the problem
I
when
think
we.
we've had one pulley problem on homework. We've had one day of pulleys and one homework problem with it.
I thought I had 3 pulley problems.
No, maybe 2
I
pulley
think
problems
so.
on homework. It was a
One
Tuesday.
kind of looked like this, but it was different.
Oh, that made
I'm
me
pretty sure
homework.
it's
I was
confused.
into it.
3. It's
It
hard.
was messing me up.
Pulleys
Yeah.
are hard.
It's tough to like try to give you enough problems without overwhelming you with homework, right? I mean,
You already do basically.
I know, but I honestly, I don't know any other way to like teach a class that than to like have you to exercise your brain. There's no easy way to get you to be able to solve problems without asking you to do them. The cop out, well, I would say the recording here, but I'll say it, like professors that just give quizzes all the time because they said, I don't want to grade all the homework because their students are just going to cheat anyway and that kind of thing, and that mentality. But that's where you learn everything by doing the homework. That's where exercising your brain.
I just think the lecture should be longer so we can go over more examples.
That's exactly what I was gonna say. I was gonna say, I don't think we should have 2.5
Yeah,
hours
'cause
in
the homework
dynamics.
makes
That's way
sense.
too,
If
this class
we
in
did-
statics too, way too fucking hard for 2.5 hours a week.
I got you.
That
Well,
takes-
see,
I don't
what
mind.
we did at Coast Guard was we'd have 3 days a week classes.
See,
And I really
3
think
days a week, an hour a
350-minute sessions, I think is so much more valuable than 275 because you just can't absorb as much stuff in that time. I can make problems shorter on homeworks and that kind of thing because now I'll ask 3 homework assignments instead of 2 homework assignments.
And your days are shorter with, you're really focusing on one thing per day because you have an extra day per week. I
Yeah.
think that would change the way a course like this goes. It's too much in one day.
But
very often.
you gotta get everybody else in the in the department on board, right?
It's a lot.
It's a lot of people's opinions that and nobody wants
It's
to
also
come.
only-
Nobody wants to come in on Friday is the problem.
Yeah.
Look how empty this building is right now.
Students do that.
I'm like,
Students
I've
do
never had a Friday off.
Really?
No. Well, I'm only second year, but I've never had a Friday off.
You're a sophomore?
Yeah. 'Cause
Taking dynamics in the first semester.
I'm doing a dual degree, so I'm technically
Wow.
a semester ahead in both of them, but I have to be in finish in 5 years. But
Hey,
yeah, physics is 3 days a week. Chem is 3, because I'm.
Oh,
civil,
yeah,
so chem is
yeah.
3 days a
Okay, so the
week,
people in the
so-
science, people in the science building, they have no problem
Math
is 3
days a week,
making
too.
thing 3 days
I
a
had
week,
math this morning.
using the Friday. I'm just saying the engineering building, engineering classes.
Yeah, no, you're right.
Yeah, almost
Yeah,
all
Calc
2
1
days a
and
week.
Calc 2 is 2 days a week for me.
Those
Calc
are
1 is 3
choice
days a week.
though.
Because we always did Monday, Wednesday, and Friday were 3-day-week classes, and then the Tuesday, Thursdays were 2-day-week classes.
Yeah, I mean, that makes sense.
Yeah. For just divvying up the work, and I always complained about the 2-day-a-week classes that they were just like, I can't do as many topics.
Yeah.
I lose people's attention span after 75.
You do.
It's
I'm
tough.
being honest, it's hard to stay focused.
It's
on
hard to stay
dynamics for
focused.
75 minutes.
Those extra 25 minutes is not as productive as the first 50.
Yeah.
It's not even. And I think it's all, personally, it's all like kind of a, because they said, well, we need to have 10 minutes between, so people get from class to class. So they're actually stealing 10 minutes from you. They're called credit hours because they're the number of hours that you spend per week. It's supposed to be 3 credit class, supposed to be 3 hours per week. But they steal 10 minutes so that they could get from class to class.
They actually take 15 because they give, on Tuesdays and Thursdays, they give 15 minutes between classes. And that's how they get from 75 to
I didn't know that. But no, actually, I think most of the time we have 10 for most. Yeah.
We're 5:30 to 6:45 minutes plus 7.
Yeah, that's the first time I've ever heard. Some class we only had 5 minutes between.
I've never had a class.
Yeah, I had one. That was, we had hard to get that teacher out of there.
I always, and you know what? And Tuesday, Thursday, it's a 9:55 start and a 10:10 and a 10:10 end. There's 15 minutes between classes. Or with an 11:10 end, there's always 15 minutes between classes. Tuesdays and Thursdays. Okay.
I'm feeling guilty.
No, my Tuesdays and Thursdays are all wonky, so.
Why?
Because I have a lab and I work, so.
That's a long.
You work on campus.
Yeah, 2 jobs, one on campus.
So I want to finish, okay, so did I get that right? I think I got it right. Hopefully, yeah, okay.
Like up to here, I would have got.
Yeah, up to here. So now the next thing that you want to try to do is try to see. All right, so we got a relationship that we could write out here. A lot of times I'll just write it out. I mean, it's not maybe necessary, but I kind of like to have like have this for myself as I'm going through this. -3a. Okay. So I don't necessarily need to put them into each other just yet, but I might need to. All right. So other piece of information that I had was that the acceleration. Yeah, okay. So I could find the acceleration because I was given the acceleration of b, but now I could find the acceleration of a. So I have the acceleration of a. It's going to be -2 times. And I've given the acceleration of b, so that's 2.5. So we know that it's going to be -5 feet per second squared. And I have to be careful about up and down when it comes to this. All right, so we said that A is moving upwards, right? Yes, and after A has moved up. So even though this is negative right here, it really kind of means that B was accelerating downwards. You just got to be careful with these signs, is what I'm saying in one of these problems. But we could find the velocity of A because we were asked to find. We want to know the velocity of C with respect to A. You know, our find, which we should have written at the top, was supposed to be VC with respect to A, so we need to find the velocity of A.
We need to find VC and VA.
Yep. So we could get VA now that we have this right here, because we know its distance and we know its acceleration, so we could find its velocity. So we find the velocity of A squared is equal to the initial velocity, which is of course 0, plus 2, acceleration of A, and delta YA, I'll call it. And by the way, that negative sign, we could just remember sure that we need to interpret that. I'll do it with an arrow sometimes to keep myself from getting confused, right? So that's it. I rewrite the thing out. An arrow and a negative sign reverse the arrow, so just rewrite the thing out. And this is just me, a note to myself, trying not to make a mistake. So we'll take that 0 and 2 times our 5 times our distance moved, which is 3.5. It's VA squared. So we had to take the square root of that, sorry. So that's going to be 2 times 5 times 3.5, and then take the square root of it. And the reason why I'm even mentioning this guy right here is we don't want to start trying to take the square root of a negative number. We know that it's not going to work. So that's 5.916 feet per second and we know it's going upwards. Now that we have VA right here, we can find C because we have this relationship, right? Whoops, could have written it up here. This one.
Like I just multiplied that by 3 and that's.
Yeah, so we have VC is going to be equal to
Negative.
a negative 3 VA. But it makes sense because this thing is going to be sliding downwards right there, right? So we don't necessarily even need to say what that negative is to the thing. A lot of times I'll just go absolute value of these things instead when it comes to the negative. I mean, there could be a scenario where the negatives would be helpful to keep track of the thing. But I think most of the time I just go, yeah, just multiply it by there and then draw an arrow next to it because I know which direction it's going. So that's 8 point, is that true?
No. 17.75. Maybe, unless I'm really wrong somehow.
I think you're right.
Thank you.
I think I made a mistake. I'm starting to think I made a mistake somewhere. 1 second.
Where could there be a mistake? It's very simple.
I know. I think I'm making a mistake somewhere. Yeah, I made a mistake on my page, I think, on this page right here. So that's my problem. It's my problem. Not your problem, it's my problem. My problem is that what I've written on the page, I believe, is incorrect.
I don't like pulleys. Can you not put them on our test?
What's that?
Can you not put pulleys on our test?
If you do make it.
Not
really-
this.
Not this, yeah.
Not this one.
Well, then we're not doing this one because I'm burning this one right here. It's gonna burn. I don't like burning them. It takes me a really long time. My weekend's gonna.
Yeah, but the Bills won. And they look like the best.
It's true.
And they look like they're gonna be the best
Yeah,
team in the league.
okay.
They look-
Yeah, we can hope.
Things just burned me on fans.
But if you know you can only be hurt so many times before you become like shy.
I'm a Jet fan.
Yeah.
So.
Well, I don't know how you and I can coexist. So after that piece of information,
I'm from Long Island. What do you expect?
I
You could be a Giants fan.
moved away a long time ago.
That would be a lot worse.
All right. So anyway, for the rest of this, we're going through the extra, going through the motions of this. We're going to say we're going to say VC with respect to A. So we have VC minus VA, and in order to do that, we have to remember that this VC is going downwards at an angle of 25 degrees. So this is, and it's going to the right, so this is going to be 17.75 times the cosine of 25, and so that's going to be just by itself, right? So that's just I, because A is just going upwards. But it's going to be going down, so we have to have a negative 17.75, and that's going to be sine of 25, and then minus VA, so it's 5.916, and that's going to be J.
Yeah, I actually understand that. It was hard. Still don't want it.
I understand. This is also an engineering skill. It's just to hold your nose and soldier on. Fun stuff will be on the way, but sometimes you just gotta be able to slog through the annoying unfun part of the job.
We do still have a little bit of time left. Can you go back to the list of things that are gonna be on the.
Yep, I will here in a second. Is this feet per second? And so, but we asked for in the problem, make sure you go back to the problem in the beginning and look for what got asked for. We need to get the magnitude and direction.
Oh, you just love asking for the extra part.
It's just, Oops, I just messed that up. 20.42. 20.95 and inverse tangent of 13.42, 16.09. So we get 13.42 and 16.09. Sure, divided atan, boom. 39.83. And so as an answer,
And that's showing in the third quadrant, correct?
yeah, so that's really 20.
Negative y positive.
Let me think. It's gonna
Negative y
be,
positive?
it's gonna be in the fourth quadrant.
Fourth quadrant. I would have just said it wrong, I was thinking it right. Wrong.
I hear you.
By the way, we can definitely coexist as Jets and Bills fans, considering I definitely am not against the Bills ever, because I just hate the Patriots and the Giants.
Yeah, well,
I don't know.
No, the Giants suck. I have to hear grow up around people, the Giants this,
Hey,
Giants.
they were good in 2011.
Yeah, the Patriots whooped their ass.
What are you talking about? We beat them in
okay,
2011.
so, for this, we would draw as a relative triangle right here. I always have to do this myself. So VC is equal to VA plus VC with respect to A.
Do you want the triangle every time?
You know, I not every time. I try to ask it once in an exam. To just because my whole purpose here, as I mentioned before, is to try to measure whether you are learning the thing. If you're capable of doing it. And so we have this VC is going that way. It's going to be a tight one right there, right? Because that's 30 degrees right there, but that's 39. So I think we're going to go up VA and then down VC with respect to A. We'll add that one to that one and it results in that one. Yeah. Oh no, maybe not, because that's right there. There's the third. This is where the 39.8 is supposed to be, and this is supposed to be 30 right there.
Why 30?
Oh,
because it was 30 from the horizontal.
Or 25. My bad. 25.
Oh, yeah, that's what you're talking about, because it was 25 from the horizontal to give it.
Yeah.
Okay.
All right, so we want to go back to.
So you just see the list. Just the list of the
Yeah.
potential supplements.
Is this thing still recording? There you go. Yeah.
Does anyone want to ask another question, or anyone want to stop the recording?
I think I'm good.
More isn't always better.
Were there these sort of like 2-in-1 problems on the practice exam problems?
I wish I had. I don't have them that way.
I'm gonna write this down.
And that will be posted too, so I can go back and rewrite the problem and then do it, like, you know what I mean? This video.
Oh, this video?
Yeah.
Would you like me to post the problems?
Oh, that'd be great if you could post problems. 'Cause
I'll post the
I'd like
video.
to go back and
I
do
prefer
that.
to post the video than the
Yeah, I
problems.
can do the video and just.
Then it's easier to. I guess a little bit. You don't know how long it takes me to write problems.
It's probably a long time, I can't imagine.
Especially on the rejects.
Make them too hard.
Make it too hard, make it too long, make it, there's,
Don't ever take something out for it being too easy.
I don't know if I've ever done that. I could burn other people's problems too. I have, like, Dr. Orlip would often give me his exam, and I would give him mine, and then we would compare. We would take each other's exam and see how long it took, and that kind of thing. He's like the only one.
You guys ever compare class averages and be like, well, look, my class is stupider than yours?
Well, I wouldn't say. Okay, so I'm the unofficial course coordinator for the dynamics, and I usually have, depending on who we have teaching, but sometimes we have as many as 5 sections, and everybody can do their own thing, and some people cooperate more than others. But this past year, I was like, hey, here's, I shared what mine, how many A's and B's and C's and so forth. Don't even want to talk about the others that I had. But yeah, we often talk. There's, honestly, I think a lot of it has to do with what time of day it is in terms of how successful students are, and when it comes to when there's multiple ones. And the night students don't seem to do as well as the day students.
Disrespect.
It's not, I don't think, it just
No,
happens to be who signs up for when, really, a lot of times.
I failed statics when I took it at night and passed when I took it in the morning.
Excuse me?
I failed statics when I took it at night and passed when I took it in the morning.
There you go. So it could be just, that could be just as important there. So I think we're done with the video. We probably won't make this one public for the rest of the world. I usually put up on YouTube because
But you just showed a whole test. That was a big thing.
yeah.